Alright, so right now I want to talk to you about the relationship between instantaneous and average velocity. In this video, you are going to calculate average velocity using instantaneous velocity. In some special cases, you can actually calculate instantaneous velocity if you know average velocity, because there's a relationship between the two. Let's say you have a ball and then you drop it, and as you drop it, you have a strobe light that takes pictures at very fast intervals. So each one of these intervals is the position of the ball during a very short period of time. Let's imagine we are given the instantaneous velocities of this ball. For the sake of simplicity, we're going to assume that those units work out in such a way that the ball starts off going 0 units of velocity, then 1 unit of velocity, then 2, then 3, then 4. So we're given instantaneous velocity. How could we actually find the average velocity of the ball? Well, we go back to the definition of what average means. If you're going to calculate the average of the height of your students in your class, then you're going to measure the height of each one of those students and then divide by the number of students. Well, the exact same thing is true for average velocity. You would add up the number of velocities you have and then divide by the number of instantaneous velocities. So average velocity is actually the sum of all the individual instantaneous velocities divided by the number of them. If we want to know the average velocity of the ball at this point right here, the way we can do that is to add up all these different velocities and then divide by the number of them. This is going to equal 0 plus 1 plus 2 plus 3 plus all the way up to 8 divided by the total number of velocities that we actually have added up, a total number of 9. If you do this calculation, the average velocity of the ball as it falls at this point is 4. What about the average velocity at this point? Well, we do the same thing. If we want to know the average velocity from this point in time to this point in time, then we can add up all of these velocities and divide by the total number of them. If we do this calculation and add up all these numbers and divide by 8, we are going to get 3.5. And we can do the same for this one. If we were to do that, we would get 3. This one is going to be 2.5. This one is going to be 2. This is going to be 1.5, 1, 0.5, and 0. Notice the relationship between instantaneous and average velocity goes from 8 to 4. It's cut in half. Goes from 7 to 3.5. It's cut in half. 6 to 3, cut in half. 5 to 2.5. All of them are cut in half. So this means there's a relationship between instantaneous velocity and average velocity. As it turns out, whenever an object is accelerating at a constant rate, average velocity is also equal to 1/2 of its instantaneous velocity. So this gives us a way to figure out average velocity if we're given instantaneous velocity. A little bit of algebra to get rid of this 1/2, we multiply both sides by 2, and we will see that 2 times whatever the average velocity is equal to the instantaneous velocity. So these equations are huge, and they give us a really, really awesome way of figuring out instantaneous velocities for objects that are going to be speeding up, slowing down, or changing directions. We're going to use these equations and discuss how we can find out the instantaneous velocity of something that is accelerating.